Welcome to the Explainer. So let's dive right into an everyday mystery. How exactly do the devices we rely on survive the absolute harsh realities of our world? I'm talking about your smartphone surviving an accidental dunk in the pool, or, your smartwatch braving a super dusty hiking trail. It isn't magic, and it's definitely not luck. It's actually the result of meticulous, highly regulated engineering and, honestly, some incredibly violent testing.
Here's our roadmap for today's Explainer. First, decoding the IP code. Second, the global IEC standard. Third, solids, dust, and water. And finally, number 4, inside the test chambers.
All right, let's kick things off with Section 1, decoding the IP code. We see these little letters and numbers all the time on tech specs and product boxes, right? Imagine you're shopping for a new piece of tech, and the salesperson proudly points out that it's IP68 rated. Ever wonder what an IP rating like IP68 actually means for your device? We intuitively kind of guess that a higher number is usually better, but those letters and numbers are actually a highly specific, standardized language, and they tell a really detailed story about the physical durability of that product. When you actually dig into the official engineering documents, the IP code is defined as a coding system indicating the degrees of protection provided by an enclosure against access to hazardous parts, ingress of solid foreign objects, and ingress of water. Basically, how well it keeps stuff out. But here's a crucial and honestly pretty surprising point. This isn't just about protecting fragile electronics from the outside world. It's equally about protecting us, the human users, from accidentally accessing the potentially hazardous live electrical or moving mechanical parts hidden inside.
Moving right along to Section 2, the global IEC standard.
Now, to make sure an IP rating means the exact same thing in Tokyo as it does in Toronto, you need a single global rulemaker. Enter the International Electrotechnical Commission, or the IEC. They're a worldwide organization for standardization made up of all the national electrotechnical committees. Their whole core objective is to promote international cooperation on all questions concerning standardization in the electrical and electronic fields. So when a company claims a specific IP rating, they're answering directly to the strict testing protocols laid out by this global commission.
And this right here is the ultimate authority, the IEC 60529 standard document. This exhaustive text describes the entire system for classifying the degrees of protection provided by enclosures for electrical equipment, with a rated voltage all the way up to 72.5 kilovolts. That's a lot of power. It details everything from the required atmospheric conditions for dust and water tests to the exact dimensions of standardized metallic test probes used to, well, rather comically, mimic human fingers. It is literally the definitive word on what constitutes a truly protective enclosure.
Okay, into Section 3, solids, dust, and water. Let's methodically crack this code numeral by numeral to understand how these ratings are actually put together. The IP code is neatly divided into two main parts right after the letters IP, which, by the way, stand for ingress protection. The first characteristic numeral, which ranges from 0 to 6, dictates the level of protection against solid foreign objects. We're talking dust, dirt, sand, and also the protection of people against access to hazardous parts. The second characteristic numeral, ranging from 0 to 8, indicates the degree of protection against the ingress of water. So, looking back at our earlier IP68 example, the 6 means the device is entirely dust-tight, and the 8 means it can survive continuous immersion in water under specific conditions. Pretty neat, right?
But here's the thing. A manufacturer doesn't just get to slap these numbers on a box and call it a day. To earn them, devices have to undergo extreme testing conditions dictated by that IEC 6059 standard we just looked at. We are talking about devices being absolutely battered by oscillating tubes simulating heavy rain, blasted by high-pressure spray and hose nozzles, and being subjected to temporary or even continuous immersion in water. And for the solid ratings, devices are locked in these crazy dust chambers swirling with fine particulate matter, and they're repeatedly poked with metallic access probes to test if a human finger could accidentally touch a live wire. It's a real gauntlet.
Which brings us to our final section, number 4, inside the test chambers.
We've seen the dry, theoretical text of the IEC standard. But how do manufacturers actually replicate these violent natural environments inside a controlled laboratory? Well, enter the brutal physical reality of WEWAN environmental chambers. You've got a sand and dust chamber that creates highly controlled, incredibly extreme arid conditions to validate those IP codes.
literally forcing fine particle contamination around the enclosure using forced air circulation. And then you have the rain and dust chamber, which subjects devices to severe water exposure, just making sure those seals hold up to driving rain and splashes. This is exactly where a device proves, once and for all, if its engineering is actually up to the global standard.
WeWan builds a whole variety of what are essentially specialized torture chambers for tech, just to meet these standards. First up, you have the 1,000-liter sand dust chamber, which perfectly simulates natural wind and sand environments for everyday electronics and automotive parts, testing for that IP5X and IP6X compliance. Now, for more extreme needs, they build a custom blowing dust chamber. That one generates military-grade, high-speed airflow, which is absolutely critical for aerospace and military applications. Then there's the massive 2,000-liter large dust chamber, tailored for heavy telecommunications equipment and EV batteries. And finally, the IPX3 and IPX4 rain test chamber features high-precision oscillating tubes and a 360-degree spray with variable pressure to validate against splash and rain. It's the whole shebang.
On a commercial scale, this rigorous testing is literally everything. Manufacturers absolutely rely on these advanced simulation solutions that meet strict international standards like MIL standard, IEC, ISO, and ASTM to confidently guarantee that their technology will actually survive out there in the real world. Just pause for a second and consider the sheer scale of that number, 2,000 liters. That is the volume of WeWan's extra-large dust testing space. To put that into perspective, we aren't just talking about dropping tiny smartphones in a box anymore. We are talking about ensuring uniform dust distribution over entire, complete machines and massive, heavy EV battery packs. The sheer infrastructure required just to test our modern technology is absolutely monumental.
So the next time you accidentally leave your device out in a rainstorm or you drop it in the dirt and it survives perfectly fine, maybe take a second to remember the intense, highly regulated journey it went on just to earn those two little characteristic numbers. Knowing the violent sandstorms, the fine dust particulates, and the driving rain your devices are deliberately subjected to in these chambers, just how much invisible engineering is protecting your modern life. Thank you so much for joining me on this explainer. I really hope it gave you a brand new appreciation for the technology we use every single day.